Hello everyone. Today we are going to solve another question 130. It is the part of top interviews question and the question is surrounding regions. We have given a M into M cross N matrix board containing X and O. We have to capture all regions which are surrounded by X and we have to convert all the zeros into X. But the check fact is we does not have to convert the zeros which are on the corner of the matrix, or we have does not have to capture those zero which are adjacent to the mm, corner of the matrix. Suppose we have in the diagram you are clearly seeing that all the three zeros are converted into x, but the corner or the board which are the zero which are at corner does not converted into x. And suppose if the zero here does not the position will if the position of this zero will replace with the x, then here in the output we have another zero in the position of x. So the solving of this method is BFS, DFS, and it can also be solved by array, but I have to choose DFS because I think it's easy. uh, uh, there are many way to execute it. I can write DFS code inside the solve function which is given in the question, but I use recursive function, so I have made another function called DFS. Here I execute it using self. Self is used if we are using making two functions inside the same class. So we use self function to call the another function of the class. So we are using self row column. If row equal to row is less than 0, here you can note the row and column are declared by m and n, not row and column. Row and column, row and col are the another variable which I have declared to identify the adjacent or the adjacent element. So DFS row call, if row is less than 0 mean the row is out of index and row is greater than self dot m. Here the self dot m is the actual length of the row and self dot n is the actual length of the column. So if the row is greater than actual rows and if column is less than 0 out of index in here, and if self dot board row column is not equal to 0 mean we have to identify those those rows which are 0. So if it is not equal to 0, return get and we will return. Else else we are not using else condition, we are directly implementing it. Self dot row column, here I using the trick called if I will firstly find for the corner element of the matrix, and if I find 0 I will convert it into hashtag, and I will convert all the corner and its adjacent into hashtag. Here I convert the element other than 0 equal to hash, and I will check for row minus 1 mean left, row plus 1 mean right, col minus 1 mean up, col plus 1 mean down. I will check for all the possible adjacent nodes for the another 0. If found, we will also convert it into hash. Now in the main function, here you can see I have declared m and n, and I have declared board. We are using self function because we have made another class. So if in this we can see self dot m. In this see we are using loop, and if this is for the checking. This loop is for the checking of rows, multiple rows, if the row present 0 or not. For either self of m, if board's ith element for every row, if in the first column, if there is a 0, I will call the dfx function. Else, if in the last self dot n minus 1 means last column, for every possible row, if there is 0, we will call the function. Similarly, in the column, in the first row, for every column, if there is a 0, we will call the function. For if for the last row in every column, last row in every column, if there is any 0, we will call the function. Now we have successfully converted all corner and their adjacent 0 into hashtag. So we can directly make two loops I and j, and we will convert all the zeros into x, or and then all the hashtag into 0. And does not have to return anything. We have to modify the board. So we using this, the board is successfully modified, and now we are going to run it. You can see it is directly executed. Thank